Okay, the title of my talk, and by the way, it's a great honor and pleasure to be here in Estes Park virtually. So I'll talk about the gem unification theory in the context of space propulsion and the standard model of physics. Next slide, please.
Is that it?
Yeah. Well, actually, there should be should be something else. I mean, there should be an agenda. Thank you. Okay. So I'll be talking about, there'll be an introduction to the space propulsion and momentum exchange, basic gem unification theory, gem theory and standard model, and then I'll summarize.
Next slide.
Yeah. Okay. First question, why is gravity E&M unification important for advanced space propulsion? Some people don't think it's important. I happen to be a partisan of the, yes, it is of central importance to have a gravity E&M unification theory. But other people whom I respect don't think it is necessary to know that any more than it's necessary to know how eggs form in a chicken's body in order to get scrambled eggs. So, it's very simple, of course, to understand, the momentum flow in just a regular rocket. Rocket exhaust momentum goes out the back end and the rest of the rocket goes forward, and momentum is locally conserved. And of course, the whole universe is happy. Next. No, keep going back.
It's doing that.
Why is it doing that?
I don't know. The wind is.
Okay. Okay. Now do this. Here, let me just come down and run
it. Okay. If they're gonna, okay. I don't know how this machine is.
Yeah, just go back, please.
Okay, back.
Huh. Okay. Here, let me just take over from here.
Okay. My apologies.
That's all right. That's all right, Jason. It's good. Sorry, we're having a little. We're having electromagnetic transitions here around Midland. So, okay. Of course, here's just a rocket exhaust, very easy to analyze. Whoops. Okay, now, let's say you have a solar sail, and so you're taking the E&M radiation momentum from a star. And of course, that's pushing on the rocket and making it move forward. Once again, it's very easy to keep track of where all the momentum is going in this problem. Of course, E&M fields carry momentum. Electron and positron orbit around a common center of mass. Here's positronium, very simple example. And of course, electromagnetic fields create force. F equals ma. Now, for Newtonian gravity, it's very straightforward to show that momentum is being transferred in the gravity field, and that the action-reaction pair on two stars orbiting each other is complete. But this is Newtonian logic. We have to go into general relativity. In general relativity, gravity really quits being a standard force. Particles follow geodesics. So they basically accelerate, but where's the momentum? So when one is attempting to unify gravity and M, especially in regards to something practical like spacecraft propulsion, one is trying to unify something that's a force with something that is not technically a force. In particular, how does one track where the momentum flows in a gravity, in two, particles interacting with a gravity field? Because the gravity field has no stress energy tensor. Now, if the spaceship is being pulled toward a star, of course, it's trivial to figure out where the momentum is going. The star is forming an action-reaction pair with the spaceship. Whoops. How about suppose in the general relativistic context, you can actually have space-time curvatures which are not due to matter. You can have a concentration of gravity waves. And if a spaceship is being pulled towards one of those, what acquires the momentum? There's technically no stress energy tensor associated with the gravity field. So there's nothing to form an action-reaction pair. So conceptually, gravity fields appear to carry momentum much differently than E&M fields. That's kind of a elementary deduction. And it's sort of like, by analogy, two very different processes are getting water to the top of a plant. You can spray it on there by a sprinkler system, or it can go up through vascular action, which means it has an active medium. And gravity almost behaves as if it's like an active medium carrying the momentum and energy between objects in the general relativistic context. Once again, there is no stress energy tensor for gravity fields. So we're in a bit of a bind. Whoops. If we could change gravity with E&M fields, it seems possible we can create momentum without local reaction mass. Now that's nice because local reaction mass, of course, is propellant. We don't want to carry any propellant. We want to basically have a spaceship accelerate through the universe and transfer momentum and energy to the rest of the universe through space-time without going into the details of any kind of stress energy tensor in the gravity field. But we need a practical theory of gravity E&M unification to do this, because we want to be able to change the gravity with E&M fields. In other words, sort of a propellantless propulsion. That is our goal. Now, I have been working for a long time, since my first paper on this was at an APS meeting in 1986. Somebody asked yesterday, will the real gem theory please stand up? Well, it's mine. I named this scheme that I was proposing the gem theory because I found a box of gem paper clips in my desk drawer and thought it would be a catchy name. It also stands for grandis et medianus, the unification of the great in the middle, the medium. So the theory I've been proposing since 1986, and I have published a lot on, people like my theory so much they stole its name. It's based on two principles. I'm not going to go into it in great detail, but the first principle is that the size of a hidden dimension, a Kaluza-Klein hidden dimension, which unifies gravity and NM fields mathematically, is logarithmically related to the ratio of the proton to the electron mass ratio. And that's about the number 42. And this very quickly yields a value for the gravity constant, which is within about a part per thousand without much trouble at all. I presented this at a lot of meetings. People have accused me of doing some kind of mathematical trick. There's no trick, it's just a theory that happens to give a right answer. The theory also gives, in the Newtonian limit, what we call a vacuum Bernoulli equation, which basically says we can have anti-gravity. So this theory looks promising. This is what it looks like in practical application, or at least at this point in its development. We can create a Poynting vector vortex. Now, that was originally invented by Nikola Tesla, the rotating electromagnetic field for the induction motor. And we have a conducting dome, and it creates a lifting force in a gravity field. So we kind of have the rudiments of what look like a practical theory. And this thing is mixing up the order of things. I'm a plasma physicist, not a quantum field theorist. Should be honest, obvious to everybody. I've always been very close to the practical. I've been trying to solve the energy problem of humanity ever since my early career. If you want to know how long I've been concerned with global warming, I've been concerned with global warming since 1975, when I undertook to try and help harness fusion energy in magnetic fields. And in the process of doing that, made the discovery that an effect in plasma physics looked just like satisfied an equivalence principle and looked just like gravity. Accelerating charged particles all in the same direction and the same rate, regardless of charge or mass. And of course, ends up giving this value of big G. And the, there. Now, how does this, you embark on a journey that is basically aimed at getting you to Mars quickly and cheaply without a lot of rocket fuel. And you don't have to follow Holman transfer orbits anymore. You basically just go in a straight line to Mars. And now, in order to do that, one has to have this unified field theory, or at least in this is the scheme I am following. And so I'm unifying gravity in M, and I've got big G, and I've got a model for gravity fields as the EM phenomenon. Wonderful. But this is a major addition to the standard model. Basically, I'm trying to incorporate gravity into the standard model. And the standard model is quantum field theory. Now, I have not come up in this theory with a quantum gravity model. And partly that is just the fact that, due to the fact that I'm not interested in that. I'm interested in going to Mars. Everyone knows that you can do quantum gravity in the weak field limit. And with graviton spin 2 particles as the quanta of the gravity fields, that's fine. But all we're interested in, when we're going to Mars, all we're interested in is fairly weak field limit anyway. The quantum gravity model will certainly come into play if we do things like try and develop warp drive, I believe. But it's not of interest right now in terms of practical outcomes. Now, what happens when one is unifying gravity in NM and the gem theory is the proton behaves like the electron is being kind of a fundamental particle. And of course, in the standard model, it's made up of 3 quarks. There's 3 quarks. The up and down quarks are, of course, highly confined. In the case of a proton, the proton does not decay. So one is left with a disconnect between the gem theory saying the proton is sort of a fundamental particle and standard model saying it is not. It's made of quarks, even though the quarks are invisible like little blue unicorns. We can't see them. Basically, the gem theory is based on just straight Kaluza-Klein with a 5th dimension. However, Pauli, even though he rejected the original Kaluza-Klein scheme as something he didn't like, later he added a new degree of freedom to it and came up with a SO3 model, basically splitting electromagnetism into 3 different parts, which became the quarks. And we can try and interpret then what are we doing when we do a Kaluza-Klein theory, and in particular, what happens when we're splitting the part of the NM field associated with the proton into 3 different parts, so that we have 3 different source fields. And of course, there's some debate as to what is the physical interpretation of charge in Kaluza-Klein. One model is that it is the speed in the 5th dimension. I understand that. However, to me, charge is the new dimension. And if you have charge and you find it everywhere in the equations in order to have a metric, the outer parts of the metric tensor in Kaluza-Klein theory, you end up pairing charge with big G. As it turns out, charge becomes a unit of distance, basically a classical particle radius sort of distance. So we can write for the total charge the constraint Q1, Q2 plus Q3 equals 1. That is, the quarks have to add up to 1 charge, 1 electron charge. But also, in the gem theory, there's an additional constraint that the square of the charges of the quarks must add up to 1. And of course they do. So you got 2/3 minus 1/3 gives you 1, and then you've got 4/9 plus 4/9 plus 1/9 equals 1 also. So that works very well. And what's interesting is that if we start looking at the, whoops, I think this has jumped. It turns out you can write a Lagrange multiplier method where you've taken basically the size of the three-dimensional quark system in terms of distances, and you're extremizing that volume size with 2 constraints. One is the constraint on total charge being 1, and the other is that the total charge squared is equal to 1, and this gives you a Lagrange multiplier problem. If you vary the Q1 through 3s, you have 5 equations and 5 unknowns, and you end up solving this, and you, lo and behold, get the quark charges as you do in the eightfold way. So that's nice. As a plasma physicist, I like this. Of course, we have 4 forces in the standard model, but so to the first approximation, the gem can accommodate the quark model without any problem at all. Of course, then the rest of the standard model is the 4 forces. We have the strong force with gluons and pions. We have gravity with gravitons. I haven't dealt with that because we're dealing in the weak field limit, for instance. We have E and M, which has the exchange bosons, which are photons. And then, of course, we have the weak field, which is W and Z particles, bosons. So where the Z has no charge, but the W's do. So one nice place of comparison is that even though the gem theory actually gives the values of the W and Z particles, their masses, and also the pion masses. And for what's of particular interest is the WZ, I mean the masses of the bosons in the electroweak theory. There's a very, very nice formula for that falls out of the electroweak theory. And so you have a cosine of a weak mixing angle, and the weak mixing angle is predicted to be roughly 30 degrees. And lo and behold, the gem theory also gives you a ratio of masses, and the two things, the experimental measurement of the ratio of masses is known, of course, and the gem theory predicts its value to within 0.02% of the actual value. So that's very, very, very pleasant surprise. And then, of course, the pions, there is no theory for the pion mass that I'm aware of that gives any accurate information. And the ratio of the neutral pions to charged pion masses, that does not fall out of the theory, but it does fall out of the gem theory, and that's within about 1/4%. So, so those are things that are nice. Like all scientists, I like to dot my I's and cross my T's on these kinds of things. So basically, the gem theory is not in conflict with, in any major way, with the standard model of physics, and in fact, is very much in agreement with it, its observations. So, in summary, gravity and E and M are now unified through the gem theory. Got big G. We've got an electromagnetic model for gravity fields. And this predicts that we can modify gravity fields with E and M. It also predicts that gravity modification flight should be theoretically possible. So these are good things. Of course, the gem theory is still in an early state, needs far more investigation. If you're listening, DARPA, as soon as you get done with this COVID thing, send me my money. In the future, I believe we will have a gravity modification craft. With no propellant. They will simply exchange energy with space-time and thus with the rest of the universe. And our first goal is, of course, to go to Mars. So thank you very much, and I do very much appreciate being given this opportunity to talk and give this kind of progress report. Thank you.